Hello friends, we are going to study supernode analysis. Previously we have studied node analysis and there were few drawbacks in node analysis. So we are going to know that drawback and we are going to overcome those drawback in supernode analysis. Coming to the supernode analysis, here this is the circuit, and now in this circuit we have to solve the value of V. The value of V we have to calculate. Then what we will do? First we will apply the supernode technique in this circuit. So here first step is to find out how many number of principal nodes are there. So first, second, third and fourth. Four number of principal nodes are present here. And second step is to make one principal node as reference node. So I am making here this reference node and we will make it to the ground. Then we will assign all the non-reference node voltages in V1, it has been given, and V2. So we have to calculate the value of V. Then the next step is to assign the current. This is your I1, this is your I2, this is your I3, this is your I4. If we want to apply node analysis here at this node V, applying KCL, we can see here that we cannot identify the current in between these two node voltages because there is no resistance present in here. Then what will happen? Our node analysis will collapse. We cannot apply here node analysis. So to overcome this problem, we will do the supernode analysis. So first of all, a question comes in our mind: what is supernode? Then I have written down here, if an ideal voltage source is connected between two non-reference node, this is your reference node and this is your two non-reference node. The definition is, if an ideal voltage source is connected between two non-reference node, then these two non-reference node will make a generalized node that will be called as supernode. So supernode will be the two node combination of two node and supernode this V and V2. So whatever the KCL we will apply at supernode, we will count as 1. We will be writing applying KCL at supernode. Then here, if an ideal voltage source is connected between two non-reference nodes, these two non-reference nodes form a generalized node called supernode. The voltage inside the supernode provide the necessary equation needed to solve this circuit. Like if we will be writing here the voltage, then 10 is equal to plus is connected to V minus V2. So this will count as one equation and this equation will help to solve this equation, this circuit. We are going to understand supernode analysis with one example. Here in this circuit, find out the value of V1 and V2 using supernode analysis. So considering supernode analysis here, a voltage source is connected between V1 and V2 which has internal resistance equal to 0, means an ideal voltage source is connected between two non-reference node. Then V1 and V2 will be what? Supernode. So we will be applying KCL at supernode. If this is your I1, this is your I2 and this is your I3, then applying KCL at supernode, applying KCL at supernode, 4 ampere is incoming and I1, I2 and I3, these three are outgoing. So 4 is equal to what we will write? I1 plus I2 plus I3, and 4 is equal to I1 is equal to V1 upon 50 plus I2 is equal to V2 upon 150 plus I3 is equal to V2 upon 75. From here we can take LCM as 150, 3V1 plus V2 plus 2V2, and this will be equal to how much? 600 is equal to 3V1 plus 3V2, and here if we will take 3 common, then 200 is equal to V1 plus V2. This is equation number 1, and from here this super node will give the required equation to solve this numerical. V1 minus V2 will be equal to minus 50, or in other way we can say that V2 minus V1 is equal to 50. V2 minus V1 is equal to 50. There would be no difference what I have written here earlier. So V2 minus V1 is equal to 50 and V1 plus V2 is equal to 200. V1 plus V2. V2 plus V1 is equal to how much? It is 200. So add these two equation. 2V2 is equal to what? 250, and V2 will be equal to what? 125 volt. And another V1 is equal to, we can calculate from here, 125 minus V1 is equal to 50. So V1 is equal to what? 75 volt. We are solving here another example on the topic supernode analysis. So here is, in this question is asking find the value of your V1. Then we have to count the number of principal nodes, this, and this. These are all your principal nodes. 1, 2, 3, 4, and 1 we will make what? V reference is equal to 0 volt. Here once V reference is equal to 0 volt. And now we will assign the current direction. This I1, this I2, this I3, this I4. If we have taken here this principal node as reference node, then this V1 and V3 will be called as what? Super node, because the ideal voltage source is connected between these V1 and V3. So we will write here the Ohm's law. V1 is connected to plus 10, so V1 minus V3 will be equal to what? 10 volt. Equation number 1. And we will applying 2 KCL, one at generalized node and another at 2. So first one, applying KCL at super node. This 3 ampere is outgoing, as well as your I4 is outgoing. 3 plus I1 plus I4. 3 is outgoing, I1 is outgoing at V1, and here I4 is outgoing and I3 is incoming. So plus I4 is equal to I3. Incoming is equal to outgoing at this super node. From here we can write 3 plus I1 will be equal to V1 minus V2 by 3. Plus I4 will be V3 minus 30 upon 5 is equal to I3. I3 will be equal to here V2 minus V3 upon 1. we are multiplying by 15. Next, 5v1 minus 5v2, 15v2 minus 20v2 plus 3, 15 plus 18v3 is equal to 90 minus 45. 45. From here, 5v1 minus 20v2 plus 18v3 is equal to 45. This will be equation number your 2. And again, now applying KCL at node number 2. Applying KCL at node 2. Incoming is I1 and outgoing is I3 and I2. So I1 will be equal to I2 plus I3. And the value of I1 is equal to V1 minus V2 upon 3. V1 minus V2 upon 3 is equal to I2. I2 will be equal to V2 upon 2 plus I3 will be equal to V2 minus V3 upon 1. Multiplying those side by 6, then this will be 2V1 minus 2V2 is equal to 3V2 plus 6V2 minus 6V3. Here 2V1 and V2 minus 2, 6, 3, 9, 9 to minus 11V2 and V3 plus 6V3 is equal to 0. This is equation number 3. So now we have 3 equation and 3 unknown. We will calculate correspondingly the value of V1, V2 and V3 by this equation. We have 3 equation, equation number 1, equation number 2 and equation number 3 which we derived earlier. Now with the help of these 3 equations we will find out the value of V1. So first what we will do, V3 we can write here V1 minus 10 and we can put the value of V3 in equation number 2, and from equation number 2 we will get equation 4, 23V1 minus 20V2 is equal to 225. So equation number 4 is important right now, and putting the value of V3 is equal to V1 minus 10 in equation number 3 also we can get here 8V1 minus 11V2 is equal to 60, and this is also important. Now we have 4 and 5 equation, 2 unknown and 2 equation. Now from here these 2 equation we can calculate the value of V1, that will be coming to 13.70. Thank you.